We still have to do an awful lot of work to this engine before it's running again. So we're just going to dive right into it here. I'm going to take this oil pump apart, just inspect it. I don't suspect there's any problems with it, but I want to verify that. So we're going to take this cap off, pull it apart, and if necessary, make some adjustments to it. Welcome everyone. If you haven't seen the previous videos on this WD45 engine, please go ahead and check them out. I believe this pump is a newer version of an oil pump. I looked on the AGCO parts website, and it seems that they had two different pumps. This might be a later model, and it may fit a D17 engine as well, although the gearing is different, I believe. I don't believe it would have had the spring in originally. This looks like a pressure release spring, but there's also on the WD-45s a pressure release spring inside the block. So that's why I believe this is a newer pump. With the pump cover off, you can see some wear in the cap here where the gears are right against it. It doesn't feel like a whole lot. I can just catch it with my finger a little bit, but we're going to take that over to the layout plate and do a little more closer inspection on all these components. So doing some more inspections with the pump, the book calls out, the service manual calls out, you can have, this is about 2 thousandths clearance from the gear to the pump body. Now there's a gasket on here, so it'd be from the top of the gear to the gasket surface. It's a little vague on that 2 thousandths. It sounds like they give you a little leeway. I try and put the indicator on here. Well, we're going to zero it out on the gear. Now, because this pump isn't sitting exactly square, I've got to move it just straight over. If I move it to a different spot on the gear, it changes. But so if I zero that off there, it should be up about 2 thousandths. And yeah, it is maybe just a little more than 2 thousandths, but really close. If I come over to this side, so I got to reset it. So there, yeah, we're right at 2, maybe just a little under. I come to this gear. Okay, we're at just over 2 as well. Here we're about right at 2. So we're very close to what they say it should be. It doesn't give it a minimum or a maximum, it just says around 2. So I feel pretty good about that. Now in these gears, they say 15 thousandths backlash. If it's greater than that, you should replace the gears. Now, I don't think you're going to be able to buy these gears, but I don't know for sure. I haven't seen them for sale. So I tried to put an indicator in here. It's a little difficult to get a good reading. It did appear to be about 15 thousandths. So if I get some slack in the gear, I have a 15 thousandths shim, and I can just push it in there. It's very snug. So we're right at 15 thousandths. I don't think we're going to be concerned about that. If I move this out of the way. Now on the pump cover, this covers up where the gears are right. You can see where the gears are riding in there a little bit. I mean, it looks like there's just ever so slight amount of wear, but this I can fix fairly easy. I'm going to put an indicator on it just to see how much that really is. I don't think it's much at all. So we've got that indicator zeroed out. Looks like this is the area probably where it's worn in the most. And we're at a little under 1/1000th of an inch, so let's go to this side. Yeah, just a few 10,000ths of an inch here. So very small, but this is something I can easily fix. So I'm going to put this on the surface grinder, dust that off till that cleans up. And we're not going to worry about any of this. The only other thing they call out in the service manual is on the pump shaft, I can disassemble this gear and check the clearance. I don't remember the number now, but they do give a number what shouldn't really exceed. I think it was 8 thousandths they don't want it to exceed. So I may check that out. We're going to try and get this gear off here. I believe that's a tapered pin. I did do a little measure, and this end here seems to be larger than this end, so it should pop out this direction. It is moving. You can see where the shaft rides in the pump housing. See a little wear there, little wear up. Actually, it looks like a little more wear up here, though I can't feel hardly any. But I'm gonna measure this, and if we get a combined clearance between the shaft and the pump housing of more than 8 thousandths, we'll have to figure out what to do. But I don't think that's going to be the case. So the pump shaft starts out at 1/2 inch. Just check it in a good area. They're just slightly under 1/2. So we're going to measure the actual shaft where it rides into the housing. And, well, yeah, it's under about a 1.5 thousandths, or not even, less than 1.5 thousandths of an inch. Okay, up towards the top, it's about 2.5 thousandths. Down here, about 1 thousandths, or a little less than 1 thousandths wear. And like I said, this was a few tenths under 1/2 inch. So almost no wear down here, a little bit of wear up here. But now we've got to measure inside the housing, in the upper part and the lower part. So to measure the inside of the pump housing and using this small telescoping gauge, .501. Let's take another reading. 0.501.5. I measured 90 degrees. I measured 90 degrees from the other measurement. So the 1 thousandths over 1/2 inch there, and the little less than 1 thousandths under 1/2 inch. We only have at the most here 2 thousandths inches of a clearance, and that's probably pretty close to what it was new. So well within range there. Now I would suspect this could be a little more in here. .503.5. Let's just say 3.5 plus, what do we have? About 3.5 at the most. At the very worst point, it's about 6 thousandths. So up here, yeah, we have a little more wear, but we're still well within the 8 thousandths tolerance they give you. We're gonna call that good on this pump. I have to order some other parts, and I seen they did have a gasket. It was only about $4, so I might just get that gasket, but I'm not gonna peel this off yet until I actually do get that gasket. So really the only thing we're gonna do to this pump is just resurface this plate here and clean it up good, possibly a gasket, and then reassemble that. So we just took 1/2 of a thousandths off this cover plate here. You can see the marks from the gear pump.
You can see the marks from the gears yet. Haven't quite cleaned up, so I'm guessing probably within another thousandths they'll clean up.
So we got the cover plate ground down now. It took just a little over 1/1000th of an inch to clean up that that grunge in there. Didn't quite clean up along the edge here, but that doesn't matter. That's off the area of the gears. So now I'm gonna demagnetize this. Because this was sitting on an electromagnet, it will probably have some magnetism in it. And we don't really want that to collect metal particles, so we're just gonna run this over a demagnetizer. I'll probably run the rest of the pump components over this too, just to make sure there's no magnetism in those as well. So I have all our pump components cleaned up. This is reground. I do have a new gasket. And so when I cleaned off the old gasket, I measured the height of the gears standing up here. And then I measured the new gasket. The new gasket's just slightly thinner. I mean, maybe like a 1/2 thousandths than the old one. So that should leave about the perfect distance for our pump gears. That should leave about just under a 2/1000ths gap. So I'm going to assemble this dry. I'm not going to put the pressure relief valve in yet. And we'll do a test to see if the gears still rotate. Now with the cover plate tightened down, it is just assembled dry, but I can turn it by hand, so it's not binding up. That's a good thing. I'm just going to take it all back apart, lube everything up inside, and then reassemble the rest of the components, and this should be good to go. So now on to the connecting rods. Last year, I looked these over, and I actually did measure the diameters. The diameters measured well without the bearings in. Looked them over. They all looked well. It didn't look like a bearing ever spun in there. But I do want to check. I want to put this piston pin in here. We want to make sure that's run or close to running parallel with the crankshaft, and then that it's not twisted one way or the other. This way. We don't want it up and down this way. Just visually, I don't see any issues with them, but there is a special fixture you can use for checking that. I don't have that, but I'm going to put it up in the milling machine, and we can test it with a test indicator. So I'll just show you that on one of them, and if that checks out okay, I'll go on and do the other ones, and if something comes up, I'll bring you back and let you know. So I have the caps, the connecting rods bolted on, and I have these flush to each other, the both halves. So the piston pin goes in on these connecting rods. They're a pinch down type. So I'm setting that. I'm holding pressure on it here. I have the little plastic cap removed on this end. We're just going to set it on this granite surface plate, holding that down until that's down on the surface plate. Then we're going to tighten that down. So that's clamping it into connecting rod end. Now you see it sitting flat. Now we're going to go over to the milling machine and set it up there. So the connecting rod setting on these parallels in the milling machine. The spindle in the machine is at a right angle to the table. I've tested that already. We're going to go over, run the indicator up and down the big side of the connecting rod here. I'm going to roughly get it on center. Okay, so I'm running it up and down there. It's within a 1/2 thousandths or maybe less. Now we're going to run it over to the piston pin area. Touch off on the edge. We're going to get the center or the high spot, I guess. Okay, now we're going to run it up. Well, that's about 4 thousandths. Again, I don't have a number in the book what it should be. Seems maybe a little much, but I'd be okay with that. I'll check this 90 degrees from the measurement we just took. Okay, this direction, it's less than 2 thousandths. I like that. So we're going to go through and check them all. I'll write it down, and if it, I'll try and do a little research, find out what they could be at, should be at. or what's acceptable. So after checking all 4 of the connecting rods, I found that all of them only had a twist in of about 0.002, which I thought was very acceptable. But then the other direction, going this way, one of them was out 0.003, the other was out 0.004, and I didn't think that was too bad. Then there were 2 of them. One was out at 0.008 and one was out at 0.009. So I would say none of them are terrible, but I don't think they're really acceptable. So I could not find any specifications for that in the service manual, either for the WD45 or for Allis Chalmers 170, 175. Other than a diesel. On a diesel Perkins engine, they did give some specs, and it looks to be about 1/1000 per inch. And even the smaller 2 are just slightly over that. But then doing a little research on the internet, it figures, or I come up with about 1/1000 per inch also for your general purpose engine. So while this isn't terrible, it's not great either, and I'd like to try and fix that. Thought about buying used rods. Of course, you're looking at $60 plus from what I can find on eBay, and there's no guarantee they're going to be any better. So I'm going to attempt to try and straighten these just a little bit on the press. Now, being that we can't visually see any bend, I don't think just a little tweak is going to hurt anything. Obviously, if you had a large bend, I would not attempt that. But seeing as how ours is so small, we're gonna try and correct it. I have this apparatus set up on the hydraulic press. So we have this thick aluminum plate here. The rod is sitting on it. I have it propped up with some aluminum shims underneath here. I have the piston pin in. I have an aluminum shim setting on the connecting rod. And so we're just going to press down at approximately a center. I have a dial indicator set up onto the pin. And now I would imagine this could move around a little bit, but with a little trial and error, we're going to try and see how much this bends and then how much it deflects and try and get it back where it should be. So I'm going to move the press down and kind of watch the dial indicator. It's going to shift around a little bit because not everything is perfectly flat and rigid. So we're just going to kind of follow it, see what it does. When it starts moving counterclockwise, then I know we're putting some pressure on it. So I'm going to bend it back down to 0. I'm going to take some pressure off, but not totally free up. Okay, the dial indicator stopped moving again on the 12. So we're going to overbend that and see if we can get it to move somewhere less than 12. I'm going to drop it down to 80. We're going to release it and see where it stops at. Okay, it stopped at about 6. I'm going to release it a little more. Okay, so it looks like we made some progress. Okay, instead of using the mill, I created another fixture. I forgot I had these large V blocks and something around here, so we're gonna set this up differently. I did compare the two between what I had on the mill and what I had done here, setting this up, and they were very close to the same reading, so I know they were both pretty accurate. So this rod is sitting on here on these V blocks. Got a dial indicator in here. We're going to touch off on this end. We're going to set it to 0. Okay, so we're at 0 there. Now if I move in here and we have 0 again, we know we've got this thing straight. So let me show you from up top here. Got about 0 here. Come back over here. We're at about 7 thousandths. So I'm going to keep working that, and till we get it well within 2 thousandths. And I'm going to go ahead and do that to all of them, and I'll let you know how it went. So after a lot of back and forth, bringing the connecting rods to the hydraulic press and bending them around, we finally got them really straight. I ended up using a different dial indicator that worked a little better when checking these. So for instance, I've got a distance of 3 inches on this wrist pin, and we're only out a total of about 1,000. So between all the other ones, 1 to 2. So problem solved with the connecting rods. So we have the bearings put into the connecting rods. We're just going to take a measurement to see if it falls within the tolerance that it should. And they should be at 2.376 to 2.377. So yeah, we're about at 2.377. So that's good. I went through the other 3 connecting rods and measured them as well, and they all chucked out within specs. So by leaving the crankshaft in the lathe, I was able to bolt these rods on with the new bearings in, just to see how they fit, just to make sure we didn't have any surprises when it went into the engine. So everything seems to move freely. And then I checked the end clearance, or the side-to-side clearance on the connecting rods. And I'll show you how I did that. So the side clearance is whatever you can move it back and forth, should be between 6 thousandths and 12 thousandths. So I have a 6 thousandth shim and a 12 thousandth shim out. So I can fit the 6 thousandths in, but the 12 thousandths will not go. So we're in the correct range. Even if I put the 6 thousandths in, it has very little movement, so it's probably closer to 7 to 8 in reality. And they all seem to be consistently the same. So now on to fitting the crankshaft. If you watch an earlier video, I did like a line bore on the milling machine, and I didn't know exactly what size diameter bore these were. There was no specs in the book, so from measuring the bearing clearances and measuring the current bearings, I determined what I thought it should be. I have some new old stock bearings. I have the rear end clamped in here, and I'm going to talk a little more about that in a minute, but while this one's clamped in, we're just going to take a measure on it and see where it's at. So with the dial bore gauge, I already have it set, but this is how I set it up. We have the micrometer set. I actually have it set to the larger diameter called out in the book. And let's see what that is a minute. So here's looking at some specs in the book. They're calling out the bearing diameter in the center and rear at 2.4795 to 2.4807. So I set the bore gauge at the larger number. So if we're hitting that number exactly, it should read 0 on the gauge. Okay, so we're just to the right of the 0. So that means it's just looks like just a couple of tenths from our number. And that's in the good side of it. So I believe we bored it out to the correct diameter. I'm going to check the center one now, but first I have to remove this cap in order to get the bore gauge in to check in here, and I guess I'm not completely sure it'll still fit. So these were bored out with the 10,000 shims in, and you could have theoretically taken the shims out and bored it out as well and had no shims in. But I kind of wanted to keep it somewhat original. Now, onto this front main bearing. This is the thrust bearing. Again, these were some new old stock bearings. I bought these, I don't know, quite a while ago on eBay. Supposed to fit the Allis Chalmers 226 and they also said a Leroy engine, which I think was I don't know if that was a copy design of Allis Chalmers or what, but anyhow, the bearings are the right diameter, and they would fit in there. The front bearing here does not have a notch in the block for the notch in the bearing, and while I could grind that off, there's actually a dowel pin. There's a dowel pin here that originally would locate the bearings, and I have those original bearings yet. So here's what an original bearing is. It had just had a notch to go through that dowel pin. Anyhow, well, I thought, well, I can notch that. I can just grind this off. But when you come to put that in now, it does not fit right. Now, the outer diameter, or the outer width here, is correct, and that would fit correctly in the crankshaft. But the shell, the legs of the shell here coming out this way are narrower than the original. So I can't have this, obviously. I considered building shims in there, and I'd have to do the cap, and that would get into a lot of work and not worthwhile in my opinion, and it would be kind of hard to keep them in there. So I thought, well, these original bearings aren't probably that bad yet. I might just rerun them. But I did find just a set of main bearings on eBay, or not on eBay, just through a website. So I've got those on order, waiting for those to come in. But for the purpose of doing a test fit on the crank, I'm going to run these old ones in there, and I want to take a measurement, see how good they are. Maybe I could have just used these yet, but so we're going to do a test fit with the new old bearings, and then eventually when the new ones come in, probably next week, then we'll fit that in and do another test fit. So I'm going to bolt this cap in, and we're going to remove this one and try and get the bore gauge in there. So we're going to insert this bearing shell in, and you want to make sure there's absolutely no nicks or burrs or dirt and debris anywhere in there. And on the bearing itself. So these are new old stock bearings. It's weird though, they have like a little discoloration on them. I'm not sure what's up with that, but there are two little punch marks, a punch mark there, and then inside the block there's two punch marks, so like that's the way they want them orientated. So I like to get them just snug with the fingers, and then you do not want the shim interfering in the bearing. Now I don't, because they overlap, they really can't. But I just make sure they're pulled all the way back, and then snug them down a little further. And the manual says on these, torque them down to 85 pounds, foot-pounds. We've got to remove this cap. Okay, yeah, so it looks like we're about, I don't know, just over 5/10 to the small side. Okay, maybe just under 5/10. So we're within the tolerance of what they said it should be at. Now we'll put that front bearing cap on with the old bearing and check that. So I have the old bearings in the front of the block. Let's just check this out. Okay, these are running about 1/1000th of an inch. Too large in diameter. Although right here, they're about right on. So again, this is the old bearing. Probably has some wear in it, I would imagine. I think we'd be okay to run this. So I did some checking. The tolerance on the crank, or the crankshaft, is on the high side of the tolerance. Now this would be also on the high side of the tolerance, but it still falls within that. This is 1/1000th to 3,7/10, and so it still falls within that range, but it's at the high end of it. But we'll see what it says, what it measures when we get the new bearing in. So I have all the bearing caps torqued down. We still have the old bearing, thrust bearing up front, but with the two new bearings in here, and everything torqued down. It spins very nice. So before I did the line bore on the block, I did notice there was, like I think mentioned earlier, there was a few thousandths difference in this front journal. So I had these newer bearings. I had them installed still with the old thrust bearing, before I did the line bore, and it had a real stiff move to it. So obviously one of these two older bearings must have had some additional clearance in it. So after I did the line bore, it's spinning very nice now. Now this could change slightly once we get the new bearing in, so we're going to recheck that. But for now, I'm going to take this apart. I still need to do a very thorough cleaning of everything inside. And when we have that new bearing in, then we'll install that and we'll recheck. Now I'm going to talk about the process of installing the rear main seals, the front seal, the oil pan, gaskets. They all kind of work together. It's a little bit of a tedious process. There's a number of steps you got to be real careful with. I'm not a big fan of how this oil pan gasket goes on here and the way these seals all go. If you do pay real close attention, you can get it right. But anyhow, Allis must have thought it was okay. They made probably a couple 100,000 of these. They had a similar design to this that did evolve slightly from probably the late 1940s into the early 1970s. So let's look at the components. First off, this isn't really related to the seals. It's the cam plug cover we have to mount back in there again. Now there's essentially two seal retainers. The first one, here's the rear main bearing cover. There's a seal that goes down in here. And then here's a cast aluminum retainer where the seal also goes down into that slot. And then here are the actual seals. One half the seal will go down in the main bearing. And then the other half the seal goes down in the slot in this aluminum retainer. And you can see some quart gaskets here we're going to deal with. Then there's other quart gaskets that go along the pan and the block. So assuming we have our felt seal, this is felt, but I don't know if this will show up on camera, there's like a neoprene or some type of a rubber in between there. That'll ride on the crankshaft. So this seal retainer, it's like a cast aluminum. Something to watch out on these. They tend to warp over time, and this one's no exception. It's reasonably flat here, and that does go up against this area of the block. Now, from what I understand, they originally may have had a gasket in there, or there was a gasket available. This one did not have one in, and it's no longer available. I'm going to put some shellac on here, but being that it's not super flat, I'm going to machine this flat. And you also got to be careful up here too. I actually laid this on the surface plate and ran it over some sandpaper. You can see where it's touching off here, but these ears on here probably can't show real well, and it tend to warp down like that. And I think that's okay way out here, but you got to be careful up here. And if you look, this bottom bolt, these are 5/16 bolts. This bottom one has no clearance between it, so you really can't adjust it at all. These holes here appear to have maybe a little bit of clearance in, although very little. You'd bolt this seal retainer on. Preferably have your seal in there already. I'm not going to tighten it down yet. Now we have these little gaskets here. They're called F gaskets. And they lay on top of here on either side. And you have to have those on there before you put the main bearing cap on. Here's a closer up view of the F gaskets. So we would already have our felt seal in here. And your seal would be in the main bearing cap. Now the crankshaft would be in here as well. I'm going to show you without the crankshaft in, but here is where the seal would ride in this area here. Then with the F gaskets in place, of course our shims are in here. Crankshaft would be in there. We'd set this on, have this bolted down. So now you're sitting on these little gaskets here. Those are important. They have to be in there. And this has to be at least up high enough to meet with the bearing cap. So I got what information I could out of the service manual as to how to do this. It's not super detailed, but you can pick up some vital information there. There's also a video put out by, I believe it was OK Tractor, from a man by the name of Don, I believe, from Don's Tractor Repair. It's an older video, but it's got a lot of good information in it. Okay, now let's go talk about the front crankshaft seal a minute. Of course, this seal is going to ride around the shaft here. Now, I actually have a speedy sleeve, a repair sleeve ordered to, there's a little groove wore in here. We're going to reseal that or resurface it. Again, visualize the crankshaft inside there. Here's our timing cover. Now this would have a seal that gets pressed in here, but you can't press it on yet. There's actually a piece of felt in here plus rubber. So with the crankshaft in, you would slide this over the crankshaft. There's no dowels locating it. Let's just temporarily hold it in with a bolt. So you need a special locating tool. I just happen to have this bushing here that worked out well. It has to slide over the crankshaft, so it fits nicely there. And then this is also the same size diameter as the seal. This would go inside there. So with the crankshaft in, you slide this over the crankshaft, and that would, this can float around a little bit. With the bolts loose, there's enough clearance in these holes that allow it to move around just a little bit. So you want to have this crankshaft on the exact center of where this seal has to go. So with that bushing in there, you would then tighten down your bolts. Now you know your seal would be centered. Then you'd go ahead and slide on your front crankshaft seal. Now onto this oil pan. If you look here, there's a radius area which is supposed to be 4 7/8 inch across on either end. It's the same, essentially the same front and back. And if you look at these corners, now this is called out in the book too, these should be sharp. Well, I wouldn't quite consider these sharp. They're reasonably okay. This one seems to be a little more rounded off. And also in the manual, it does say you can build them up with solder. So I believe they were soldered from the factory. This is actually a pretty difficult stamping to stamp all at the same time, get all these bends in correctly. So I think that's what they had to do from the factory, is build that up. I may try and, at least I wanted to experiment with it, solder it out and then file it back into shape again. And being that these are, again, a stamping, this pan is pretty good. If these bolts are tightened down over at various times, they would tend to bell mouth these holes out. So you want to make sure they're knocked down there good and it's reasonably flat. If this oil pan gets twisted or something along that line, you no longer have this true radius area here. You may have to find a different oil pan. So you've got a right hand and a left hand oil pan gasket that goes onto the block. Now I think the manual tells you to shellac it to the oil pan. I'm going to put it on this way, so I'm going to shellac the block. Then I may put actually some of that black Permatex, a thin coat all around these edges here. Because after a while, that thing's removed on and off a few times. It gets a little bit tweaked, and if there's a little bit, so they're both our gaskets on there like that. And it would be a good idea to have some locating pins. These are just 5/16 bolts cut off. Put those in the 4 corners, roughly. Now you have 2 of these quart gaskets here. And they're gonna go around this radius area on the cap here. And if you look on the timing cover, they're gonna go around the radius area there. Now I will set that pan on there, but I'm not actually gonna try and fight with these at the moment. So that'll go around there. And then the one area, of course, here's where a lot of stuff's got to come together, and this is a high potential area for it to leak. So you've got to have your little F gasket in there. This has to essentially come up to the edge here, and here's where you want to put some Permatex. Probably put some underneath and then around in this corner, and that way, this is where that sharp corner in the pan comes into play. You want to at least have it reasonably sharp, but if it's not perfect, a little Permatex would help that out, but obviously if you got too much Permatex, it's not going to hold well. Same situation in the front. Now in the past, and I've done a couple of these engines, I've put a light coat around this bearing and I think a light coat on the pan. They say you don't need to do that and probably shouldn't do that. So I'm going to try this one without doing that, but I will make sure I have Permatex in these corners. So then our pan would go on like so. And if your dowels line up nicely, it's a pretty good chance your pan is not tweaked. Now there are special clips to hold these seals in place, and I actually do have some on order. I think it was about $10 for 10 clips, or 8 or 10 clips. So I'll install those clips on there, and that would just help hold this gasket in place. One other note about these gaskets, being that they're straight and you're fitting them into a curved area, they say you should pre-bend them. So you would like stick them inside this coffee can, let them set maybe a few hours or overnight, and that'll just help keep it in place a little bit better. So then your gasket's going to fit in here. Of course, you want to have that in place when you drop the pan on there, and it's supposed to compress it enough so where you don't need to seal it. And when you come into this corner here, that's where they want you to put some Permatex on. That's probably the highest potential for it to leak. And again, same around here. Of course, you want to make sure these surfaces around these radiuses are good and clean, and they're not beat up at all. If there's any big nicks or craters in there, you want to fix that. So if you're really careful, pay really close attention to what you're doing and inspect things closely before putting it together, you should be able to successfully get that sealed, and it should last a long time. So the new front thrust bearings came in today. We're gonna see if they fit. These, I think these may be genuine old stock. Get those installed, hopefully they fit, and we'll take a measurement, and then we're gonna install the crankshaft. Well, I put the new bearing in and had measured it, and it was about a 0.5 thousandths tighter on the tolerance, which is good. With our crankshaft in again, I've had it in and out several times. We have a really nice fit now. So I always like to test fit these crankshafts before putting the pistons and the rear seal on, because when you do that, it creates friction and you can't really tell how well it turns. So even if you measure everything, which I did, and we do have all the proper clearance between the journals and the bearings, you can't always tell, if this crank were tweaked a little bit or if your block were off. Even with a proper clearance measured individually, if something's out of misalignment, then it still won't turn this nicely. So feeling very good about the line bore we did. That was more successful than I thought it might be, so that's a good thing. Still have to put the rear main seals on yet. The cap's got to get bolted on, and I have to the seal retainer has to be bolted back on yet, and then I have to pull these caps off again, of course, to get this crank off, but then we're going to put the seal in that cap. But first, before I pull the crankshaft out, we want to check the end thrust. That's the amount the crankshaft can move back and forth. And this front bearing that we just put in, that is what determines the end thrust it goes between your crankshaft and the bearing. And so the end thrust clearance on the crankshaft should be 0.003 to 0.007 of an inch. So we're going to set up a dial indicator on the end of the block here up against the end of the crank. So the other day, my grandson was playing with this dial indicator here. He wondered what it was. If you're watching this is one of the things we can use it for. So the indicator clamped onto the block. I have it set at 0 now, but we're just going to push it all the way in. And then we're going to re-zero it. Turn it just slightly just to make sure it's seated well. Now we're going to pull back on it and see how far it moves. Let's get honed right in here. So yeah, I don't know if you can see this, but we're right at that 0.003. You should be at 3 to 7, so we're right on the low end of that. We've got the proper end thrust on the crankshaft. And we're going to install the rear main seals and put the crankshaft back in. We've got to put the tappets in, and I'll check those out first. One other note on this crankshaft, I put a ready sleeve or a repair sleeve, speedy sleeve, goes by several different names. There was a little bit of a groove where in this crankshaft where the seal rides, so we've got that fixed up. So we're ready to put the rear main seal retainer on. I have the seal in there. You can see the seal sticks up a little above the split line here. To me that just seems a little excessive, but they say don't cut that off. That's supposed to compress. The rear main cap has the same situation. We have that seal put in. It sticks up a bit. So this is like a die cast extrusion. I remachined this surface here. These things can warp a little over time. You can see it didn't clean up on the ears out here, but that shouldn't matter. Our sealing surface really only has to be in this area all along here. So I'm going to put some of this old school shellac on here. At one time, apparently, you could get a gasket for this. There's our shellac. Also, when I put the felt seals themselves into the seal retainers, I used shellac to hold them in also. So there's a little gasket called the F gasket that goes back on top of here. This is mostly flush right now. Now there is that 10,000 shim that goes in the bearing cap, so I want to measure that gasket once. So this seal retainer measures just a couple of thousandths below this main surface here. These little gaskets are 16 thousandths of an inch thick. And with a 10 thousandths thick shim that goes underneath here, that'll work out well. That'll allow that to compress down there a little bit. There's some little bit of preload on there, so that should seal off okay there. The bolts holding the seal retainer on are being torqued down to 15 foot-pounds. So I'm also going to put some shellac on the bottom of these to hold them in place. So we're about ready to drop the lifters in, and I'm going through and measuring them, and then I'm coming over to the area where they go in the block here. The book tells that it should have a combined clearance when new of 0.5 thousandths to 2.5 thousandths. Now when I measure the lifters, there's very little wear on the lifters, and then a little more in the bore in the block here. I've got a combined clearance of about 4 thousandths, but they do not give a maximum wear, so I don't know if they're not concerned about it. The WD45 manual doesn't even mention it, so maybe that's not a concern. And I don't know what you'd really do about it anyhow. You'd have to bore these out oversize, and then you'd have to have an oversized lifter, and I'm not aware that there is such a thing. I've never even heard of that, or have them custom made. And these are hardened, and I can about imagine what the cost would be on that. Just curious if anyone knows what you would do about in that situation. Do they make oversized lifters? Please drop a comment. I'd be curious to know. So we have all the lifters marked so we can get them back in their same locations as they originally were. Just going to put some of this assembly lube on and drop them in location. So next we'll put the crankshaft back in, and we'll get that torqued down. And then I'll probably set this on the engine stand, and we'll put the camshaft in. Yeah, we'll put the camshaft in, and then we'll put the timing cover on, get that seal aligned, and then we're ready for pistons, I believe. So I'm going to put some of this engine assembly lube on these bearings. Put some on the thrust area of this bearing. And now we'll drop the crankshaft in. You just want to make sure everything is very clean. Make sure our shims are not interfering with the bearings. We'll put the caps back on. I'm going to put some of this engine lube on the caps too and make sure everything's clean. We don't want any debris in there when we drop those on and tighten them down. I always like to just pull these shims back just to make sure they're away from the bearing. I just like to get them finger tight, and then because these caps are not positively located on this block, it can float around a little bit because of the clearance in the bolts. I'll get it snug with my fingers, and I like to spin this around a little bit just to give it a good chance of centering itself on there. Now it has a little more friction now because we have the seal half in here, and that puts some more friction on there, so it doesn't turn quite as freely as it did before. One other thing I didn't mention either, you want to lube the seal up around the surfaces it's going to spin on the crankshaft journal. So I've done a few of these engines before. One thing that always concerns me is that I want that seal stuck out on the two halves of the seal retainer and the bearing cap. I always get concerned that it's going to distort this bearing cap when I tighten that. So we have these 10,000 shims. I have these snug down. Right now the shims are tight, so it must be pulling it down okay. I don't know exactly where the ends of that seal goes, but I've just got to trust that it gets compressed correctly. So now we're just going to put the final torque on these bolts. The manual says 85 foot-pounds. I just like to rotate it every so often as I'm torquing it, make sure we're not distorting something. It definitely has more friction on now with that seal in there like that. We can't just freely spin it. Well, I believe that's good. I'm going to wait to install the oil pump on until after we have the pistons in. Now as we get ready to put the camshaft back in and the timing cover on, a couple things to take note of here. If you see this, there's actually a bolt sticking out here. If you look at it from the other side, it has a lock nut on it and then a bolt. And that's an adjustment for the camshaft end play. And that's got to touch off, or there's a certain gap, I don't remember what it is offhand, that it's got to maintain to this bolt here. Sometimes these things get roughed up and scored up a bit. This one is a little bit, but I'm going to take this bolt out here, I'm going to take this bolt out here, and I'm going to resurface them on the surface grinder. But now, an interesting little story on this camshaft. When I got the tractor, I got it running, it ran, it had a funny tone to it. I've heard these engines run plenty of times before, and then something which was just off about it. And I knew it was low on compression. I knew the cylinders, I did a leak down test, the cylinders were worn badly. So I didn't think too much of it. I figured it was probably related to that, but it didn't seem to matter what RPM you had it at, idling or full, it just sounded off. So when I'm taking it apart, I look, if you see there's a timing mark here. On this cam, there's actually a line. There's typically a line. There's a line. There's typically a line. There's a line here and a dot. And that was one tooth off from timing. So I don't know if it had been that way its entire last rebuild, because this thing had been rebuilt before, because it did have the oversized pistons and sleeves in. So had it been running that long with that timing off like that, or the cam timing, I don't know. But that probably would explain the unusual tone the engine had. Now, to make things a little more confusing, there's typically just a line, a mark on these cams, and then I see here there's a dot here as well. No, it was a one tooth off according to the mark up here. So I didn't know if I had the wrong crank gear in here. I wasn't quite sure what was going on. So I dug up another cam gear I had laying around, and if you can see the mark here on the tooth. And so I looked at that in relationship to the keyway here and compared it to this one. So it should be this mark here. So those line up. So I'm confident the way it goes together now. I don't know what that other dot is down there. If you look these cam gears over a little bit, you see a few differences, but they do have the same part number on them. Anyhow, we're going to fix up resurface these bolts here and put the camshaft in and put the timing cover on. So now with the camshaft journals lubed up with assembly lube, and then I put some lube on the cam lobes themselves. We're going to put the camshaft in. Now I've got to make sure we get it timed to the marks here. There's only one mark to line up, so it's super simple. So we've got the mark on the crankshaft gear lining up with the mark on the camshaft gear. Now we want to check these gears for backlash. I've got to get the dial indicator out and then look up what the specs are. So I'm going to zero this out. The specs call out not to exceed 0.010 of an inch backlash. So here we've got 0.006 of an inch, so we're within specs. I'm going to rotate it a turn and check it again. Okay, so I went about 1 revolution on the crankshaft and the camshaft gear. I believe it's a 2-to-1, so we're about 180 degrees on the cam gear. Okay, here we're showing about 0.005. So I think that's good. So we're ready to bolt the timing cover on. I have the gasket set on there. We're using this high-tech gasket sealant that's on both sides of the gasket and the timing cover. And then where the timing cover bolts to the block, we also have that sealant applied. Now we have our locating tool. That's going to fit over the shaft, and it's going to locate it to the timing cover. So it fits inside where the seal goes in. So now we just have to tighten up the bolts. These are all 3/8 bolts, and they need to be torqued down 40 to 45 foot-pounds, the book says. Eventually, when the governor housing gets bolted onto the back here, there's a couple more bolts that will go in as well. Now to establish the camshaft thrust clearance, one source says it needs 6 to 10 thousandths of play back and forth. Another manual says tighten this up, hand tight until you feel it, a little pressure on it, and then back it off 1/6 of a turn. And doing the math on 1/6 of a turn, that would be one segment on this nut here. That would equate to about 9 thousandths. So we're going to do the 1/6 of a turn instead of trying to get a dial indicator down in there. So we're going to set our jam nut. And call that complete. Now we still need to drive the crank seal on. So to do that, I believe I can use our alignment bushing to push that seal in. I'm going to lubricate up this seal with some oil. I'm going to get a little in that, there's a felt part of this seal too. There's a rubber part here that goes to the inside. I'm just going to put some oil on the shaft as well. It's a snug fitting seal. Gonna need a longer driver. Okay, that's appears to be bottomed out. I know these seals do stick out somewhat, so now I'm going to lift this up. We're going to set this on the engine stand so we can rotate it around, and we're going to work on the pistons and rings. We're going to first check the fitting of the rings, and then go ahead and install the pistons with the connecting rods. So as I'm getting ready to install the pistons into the sleeves, these sleeves and pistons were purchased new in a set. So I wasn't even going to do any checking. I just assumed everything should go together correctly, and it still may. But so I did decide to go in with a bore gauge and check all of these cylinders, or the liners. So these are supposed to be a 4 1/8 inch bore. So I set the bore gauge to 4 1/8, and these two, the front two cylinders were pretty much exactly 4 1/8 in both directions. I measured it in two directions, 90 degrees to each other, both the top and bottom, and they're about right on. When I came to cylinder number 3, it measured about a thousandth, maybe a thousandth and a half oversize, but it was pretty close from either direction. And then when I came to the final cylinder here, it was about 2 thousandths wider here, or excuse me, it was about 2 thousandths over the nominal 4 1/8, and it was about 2 thousandths under in this direction. So this cylinder seems to be a little egg-shaped. So did it come that way new? Well, it is new. So I thought, well, maybe I did not measure the bores inside where these fit. There is some clearance in there. I thought, well, did the bores inside warp somehow? And when I pushed this in, it egg-shaped it. I don't remember it fitting in there that difficult, so I'm guessing it was probably that way from new. So that is a little concerning to me. I don't see a tolerance in the book of what that should be. I think that is probably a little much, but I don't know what to do about it at this point. I decided to go ahead and put it together this way. It'll give like I said, 2 thousandths difference in either direction. And then I went on to measure these pistons. The book gives you some dimensions. Now these would be actual Allis Chalmers pistons the book is telling you about, and they'd be 4 inch. It should be about a 12 thousandths difference measuring from the skirt, because they're cam ground, and these are about 30 thousandths. So I'm assuming, being that this is a different manufacturer that meets their specifications on how this thing is going to expand. But the service manual calls for a clearance at the widest point of the skirt from 2.5 to 4 thousandths. And when I measure these front two cylinders, of course, they're right on. I'm only getting about a 1.5 thousandths clearance. Now, is it in the geometry of this piston where it doesn't require quite as much clearance? I don't know. I did fit them both in there. They both slide up and down okay, but the clearance doesn't quite meet what the book says. So I have decided to run them, but I am glad I measured this. So if I have any issues, I'll probably know where to look if it gulls up. But the one that's further out around this rear cylinder, it actually goes in the favor of adding extra clearance. So I'm not too worried about that. But now I'm going to go ahead and check all these rings. So there's 4 sets of rings that go in each piston. I put one of the top ring in here, and they want to measure the gap. The one manual I have says between 7 and 17 thousandths gap. When I measure this one, it's about 15 thousandths, so that's good. So I'm going to go through, as I measure each ring, I'm going to go put it on the piston, and then I'm going to go through and do all of them that way. If there's any issues with that, I'll bring it back and let you know. Now I've got connecting rods connected to the piston pins and installed. There is a procedure for doing this in the book. The journals are not on center with the cylinders. Let's take a look at that. Well, if we take a look down in the cylinder, it's kind of hard to tell in the camera, but you can see the journal's set further back from the cylinder. So these piston pins are clamped onto the rod with this bolt here. There's like a split rod in there that crimps down on it. This bolt side has to face towards the camshaft. As you can see, they will be offset in there, similar to that position. So now I'm going to go out and clean out all the cylinder walls thoroughly, and then we're going to drop the pistons in. I'll probably do the center two first because that crank position is in a spot good for that. And then I'll rotate the engine 180 and put the other two pistons in. So we're getting ready to drop in the pistons. I'm going to coat the pistons in the ring area with this Marvel mystery oil. But I'm also going to coat down in the cylinder walls as well. And we're going to use this ring compressor. We're going to drop them in these two cylinders first, and we're going to rotate the motor over and connect the connecting rod, and then go back and do the other two cylinders. So I got some plastic caps I 3D printed, put onto the connecting rod bolts. We've got to make sure the screw part of the top end of the connecting rod faces towards the camshaft side, which is over here. So I'm going to get the other one started, and we're going to flip it around. So I have some engine assembly lube on these bearings and on this journal. We're going to put these caps on and torque them down. And then flip the motor back over and drop the other two pistons in. I'll probably rotate this crankshaft 180 degrees first. So you've got the pistons and connecting rods in. I just did a double check, make sure the rods were in the correct way. The bolts need to be facing towards the wrist pin bolts need to be facing towards the camshaft. I double checked that everything was torqued down correctly. So before we put the oil pan on, we still need to put the oil pressure relief valve back in and mount the oil pump back on. We have the oil pressure relief put in now, the oil pump put on, and still turns like it should. So we don't have anything binding up. Next thing to do is put the oil pan on. So for attaching the oil pan, we're going to use some of this here on the gasket itself that bolts or that mounts to the block, engine block. And then this stuff here on the oil pan itself. The oil pan is a metal stamping and it's not a precision flat surface, so that just helps fills in a little bit larger gaps. We have the end gaskets in this coffee can right now. We're trying to make them round. So I already described how the oil pan with the gaskets all go together. I'm not going to explain that any further. We're just going to watch it take place here. Now we're taking the end gaskets that are made out of cork that go around the curved part of the ends of the pan. We're attaching these little clips to help hold them in place, and we're going to do that on both ends. Switching over to the engine block now, we're going to lay these cork gaskets on the right hand and the left hand side of the engine block. We already have some of that Permatex applied so they stay in place better. Now I'm installing the oil pan locating dowels. They are just a 5/16 bolt cut down just to help align as you drop this pan down onto the block. Now we're putting that black gasket sealant, RTV sealant, on the ends where these curved oil pan gaskets go around, and then we're going to spread a thin layer all around the right hand, left hand sides of these gaskets on the block. Okay, so now we're ready to drop the oil pan onto the block. We're locating it on our dowels, and we already have the curved end gaskets in place, held in by those clips. And it's just going to kind of crush around the round openings in the castings on the main bearing cap and on the front timing cover. Now I'm going to put in all the bolts going around the perimeter of the oil pan. I'll thread them in by hand as far as I can, and then we're going to come back and slowly torque them down evenly, just kind of going around and around. I want to try and squish those gaskets and that sealant evenly. Now I'm doing a visual inspection of those curved gaskets on both ends of the oil pan. From what I can see, everything looks like it pressed down evenly and didn't shift out of place at all. So I think we're good to go there. Well, we're going to end the video here. In the next video, we're going to push the tractor in here and start installing the engine. And I'm going to wait and put the head on until we have the tractor in here and the motor's already in. So thanks so much for watching. Hope to see you in the next video.